Okay, so we are going to continue with the packet today. So now we're going to continue where we left off, which is example 5. So what we're doing here is we are multiplying radicals with numbers and variables. So here, 6 times 3 is 18. M squared times m squared is m to the 4th. And so now we can simplify that by what's the biggest number that can go into 18? That's 9. And I'm left with m to the 4th. I can simplify radical 9 and radical m to the 4th. Radical 9 is 3. Radical m to the 4th is m squared. And I'm left with radical 2. Letter B. Okay, so get that down. So what we did was we just multiplied the inside and we simplified by using those radicals. Now, letter B, what I'm doing is I'm multiplying 3 times negative 4, that's negative 12. And then I'm going to multiply the radicals, that is 16 x to the 4th. Well, that breaks up into negative 12. 16 is a perfect square, so that's actually really good for us. We could just leave it there, and we could leave x to the 4th as is. Now, the square root of 16 is 4, and the square root of x to the 4th is x squared. Okay? So this is negative 48 x squared. Okay. Letter C. I have 4 times negative 4, and that is negative 16. And then on the inside, 4 times 8 is 32. X to the 6 times x is x to the 7th. And now we ask ourselves, what is the biggest number that can go into 32? And that is going to be 16. And I'm left with square root of 2. And then it is x to the 7th. Remember, that's an odd number, so I pull one out. And I'm left with x to the 6th. So which ones can I simplify? Radical 16, radical x to the 6th. So this is negative 16. Radical 16 is 4. Radical x to the 6th is x to the 3rd. And remember, whatever does not simplify will stay inside the radical symbol. So this is 2x. And then so this ends up being negative 64 x to the 3rd, radical 2x. Okay. So go ahead, do the DIYs on your own. So pause the video, or for the sub, please pause the video and have the students work on these. Now, the first DIY, I multiply 2 times 22. That gives me radical 44. And I'm left with x to the 6th, x to the 10th. I multiply that. Remember, when you multiply exponents, you multiply powers, you add the exponents. That's x to the 16th. And then the largest number that can go into 44 is 4. So this becomes radical 4, radical 11. And what I'm left with is I'm left with x to the 16th. Okay? So radical 4 is 2. Radical x to the 16th is x to the 8th. And I'm left with radical 11. Letter B. Letter B, I multiply 5 times negative 4, that's negative 20. 2 times 8 is 16. And then x to the 7 times x squared is x to the 9th. So now I could separate this into negative 20, radical 16, radical x to the 9th. No, x to the 8th, radical x. Remember, since it's odd, we need to take one out. And so now radical 16 simplifies to 4. Radical x to the 8th simplifies to x to the 4th. And I have radical x. So this turns into negative 80 x to the 4th radical x. Okay, letter C. I multiply 4 times 3, and that's 12. 15 times 3 is 45. And then I add my exponents, that's y to the 10th. So this radical 45 is 9. The biggest number that can go into 45 is 9. So that breaks up into radical 9, radical 5, radical y to the 10th. Radical 9 is 3, so this is 12 times 3. And then radical of y to the 10th is y to the 5th. And I'm left with radical 5. And so now this is going to be 36 y to the 5th, radical 5. Okay. Now, if I have, what I'm going to do now is I'm going to go back to something we did a couple days ago with the Pythagorean theorem. But now we're going to talk about giving exact answers. Remember last time when we did the Pythagorean theorem, we used the calculator to get square roots. However, sometimes in geometry, they want exact answers. They don't want approximations. So you're going to leave your answer in square roots. You just go ahead and simplify that. So look at part A, and I have a squared plus b squared is equal to c squared. Right? The legs go here. And this becomes 25 plus 100 is equal to c squared. 125 is equal to c squared. Now, I'm going to square root both sides to get rid of the square. Now, instead of just putting that into your calculator, we're going to simplify it by using square roots. The largest number that can go into 125 is 25. So this is radical 25, radical 5. That's equal to c. And so my answer here is c is equal to 5 radical 5. Because radical 25 is 5. Now, letter B, I have this. So now I'm looking for my leg, right? I'm looking for my leg, which means that I have my C here. And then what I'm going to do now is I'm going to use Pythagorean theorem, but I'm going to use it where I have my C. So this is 12 squared plus b squared is equal to 18 squared. This is 144. 18 times 18 is 324. I subtract 144 and I get 180. And so now I ask myself, what is the largest number that can go into 180? Or no, I'm going to square root both sides. And so now let's go ahead and simplify the square root of 180. So I ask myself, what's the largest number that can go into 180? And let's think about that for a minute. Is it... I got it was 36. So B, because 36 times 5 is 180. So this is square root of 36, square root of 5. So B is equal to 6 root 5. Okay. Oh, sorry about that. 6 root 5. Now, we're going to talk about the division property of square roots now. if you have square roots, you can divide them. So for example, if I have the square root of a over b, it's the same thing as the square root of a over the square root of b. That's basically what the division property of square roots say. And you've kind of worked with these before, I think, last semester. So let's do a couple of examples. Go to the back. If I want to simplify this, the square root of 64 over the square root of 49, this is just square root of 64 over square root of 49. And that's just 8 over 7. That's what you've already known how to do. Now look at letter B. I have this and I was like, oh, can I actually do anything with this? Well, see if you can simplify 8 over 50 first. I know 2 can go into both. So this turns into 4x to the third over 25x. Now remember, when we're dividing powers, I could just subtract the exponents. 3 minus 1 is x squared. So this is just really 4x squared over 25. And now I could take, it is just on the top, it's square root of 4, square root of x squared, over square root of 25. Okay, make sure you understand what happened here. What happened was I divided each by 2 to get this. Then I subtracted the exponents. And then now I'm just going to take the square root of the top and the bottom. So the top is just 2x, the bottom is 5. Okay, and then the last one, this is x and this is z, so they're not the same, so we cannot subtract the exponents. So what I'm going to do is I'm going to take 36, and then now I'm going to split up x to the 5th into x to the 4th, and just x, and then on the bottom, it's the square root of z squared. So on the top, this becomes 6x squared, square root of x, and on the bottom, this becomes z. And that's my answer. So that might be a little more complicated, but just follow the steps and you should arrive at the right answer. Okay, now let's look at the DIY. Here we want to simplify the following radical expression. So the first one, oh no, do this on your own, pause the video, and then resume it when you guys are done. So the first one is square root of 144 over square root of 9, and that's just 12 over 3, which is really just 4. Okay. The second one, now you can simplify this. 36 divided by 4 is really just 9. And z to the 5th over z to the 3rd, if I subtract that, I get z squared. So this is square root of 9, square root of z squared, which is just 3z. Then the next one, I have radical of 35y to the 3rd over z squared. Now, 35 is 5 times 7. So I can't really do anything with square root of 35. It's actually just going to stay there. But I can simplify y to the 3rd and z squared. So this turns into 35 y squared y. And on the bottom, it's just z squared. I can't simplify the square root of 35. So what ends up happening is the square root of y squared is y. And then what I don't have is 35y goes here. And the square root of z squared is z. Okay. Now, the last thing we are doing is we're doing something called rationalizing the denominator. Now, in math, we usually do not want radicals in our denominator. Okay? It's just much more convenient to have them in the numerator. So we're going to do something called rationalizing the denominator. Now, I want you to take note of this. If I have root 2 times root 2, it's root 4. So it's just 2, right? Now let's think about root 3 times root 3. Root 3 times root 3 is root 9, but what is the square root of 9? 3. If I have radical 4 times radical 4, it's radical 16, and it's 4. So look, if I'm multiplying by the same radical, the number is just what the radicand is. So I could have big numbers, and I don't even know the multiplication, but I know radical 24 times radical 24 is going to be 24. Even if I have a number like 956 times the square root of 956, the answer is 956. So we're going to use this to help us do these problems. So remember what I told you, I do not want a radical in the denominator. So what I'm going to do, look what I did here. If I multiply it by itself, the radical goes away. So that's what I'm going to do. I want to multiply the bottom by radical 3. However, you can't just multiply it by radical 3. You need to multiply, this is a fraction, so if you want to come up with an equivalent fraction, I need to multiply by 1. So radical 3 over radical 3. So the way to do these problems, to simplify them, is you look at the denominator and whatever that radical is, you multiply the top and bottom by that radical. So now this is just radical 21, and what we talked about before, radical 3 times radical 3 is just 3. Now you should always ask yourself, can radical 21 be simplified? No, there's no perfect square that goes into 21, so that's my answer. Okay? So let's try the next one, radical 2. So I'm going to multiply the top and bottom by radical 2. Now, this is a 9, so it does not have, I don't multiply, I just put on the outside. And radical 2 times radical 2 is just 2. That's my answer because I cannot simplify radical 2. Let's look at letter C. Multiply the top and bottom by radical 2. And so this becomes 6 radical 2 over 2. You can simplify this. This is 6 over 2. 6 divided by 2 is 3, so my final answer here is 3 radical 2. Now letter D is radical 6 over radical 2, so I'm multiplying by radical 2. And so this becomes radical 12 over 2. But you should always ask yourself, can I simplify that radical? Yes, because there is a perfect square that goes into there, which is 4. So I could break it up into 4 and 3. And radical 4 is just 2. So 2 divided by 2 is 1. So my answer here is just radical 3. Okay. Okay, let's go to the next problem. I have 3 radical 6 over radical 15. I multiply the top and bottom by radical 15. This gives me 3 radical 90 over 15. Now, radical 90, what's the largest number that can go into that? That's a perfect square, 9. So this is just 3 times radical 9, radical 10 over 15. I'm going to continue my work down here. What is radical 9? It's just 3. So I have 3 times 3 is 9 radical 10 over 15. And I could simplify this by dividing, it's 9 and 15. It can't be divided, but I could simplify it by a 3. So this is 3 root 10 over 5. And that is your answer. Okay? So the main thing here is look at your denominator, and whatever that radical is, multiply the top and bottom by that radical. So take some time to do the DIY. It might take you a while, but I want you to really work through it, and then pause the video, resume when you're done. Okay? So here are the answers for the DIY. The first one, you multiply top and bottom by root 3. So this becomes root 15 over 3. You cannot simplify root 15, so it stays like that. Letter B, I multiply top and bottom by root 6. That gives me 3 root 6 over 6. I can simplify 3 and 6 by 3. So that is just root 6 over 2. Right? There's a 1 here, but we don't really write the 1 in math. Okay, letter C, multiply top and bottom by root 3. So this becomes root 18 over 3. Then you ask yourself, can I simplify radical 18? It's radical 9, radical 2 over 3. Radical 9 is 3. Okay. And then 3 divided by 3 is 1, so I'm just left with root 2. Okay. And then the last one I'm going to do here, multiply top and bottom by radical 2. This gives me radical 20 over 2. Radical 20 can be split up into radical 4, radical 5 over 2. And so this is 2 root 5 over 2. And the 2's cancel, so I'm just left with root 5 as my answer. Radical 5. Okay, so now I want you to try and work on the worksheet that I have for you. And you're going to turn in, I'm going to check it tomorrow.